all these examples look good until you want to start and write your own thresholds. Let me show you what I mean by that. So for example, here we have here HTTP request failed. So kind of like maybe know how many requests have failed. So what if we write something like count, and this should be smaller than 5. For example, what we want to say by this is that we don't want more than 5 failed requests. So let's run this. And as soon as we do this, we're going to get this error. And whenever you're getting an error, first of all, don't freak out. Spend 1 minute and try to understand what the error is trying to say. So in this case, it's telling us invalid threshold count smaller than 5 applied on metric HTTP request failed. Reason: unsupported aggregation method count on metric of type rate. Supported aggregation methods for this metric are rate. Now, right now, this error is like, what? I don't understand what I should do and how to fix it. So, in this lecture, we will discuss a few theoretical aspects about these metrics before digging further into threshold. Now, essentially, these metrics that we see here, they kind of like fall into 4 different categories. And I just want to go over some examples so that you can better understand what is the deal with these categories and why do we have these different types of metrics. Now, the first type of metric is a counter. Now, essentially, a counter is something that counts. It adds values like I have 1 request, I have 2 requests, I have 3 requests, and so on. So it kind of like keeps track of what has happened. I'm here at the K6 documentation and I'm looking here at the built-in metrics. So these are metrics that you already have. And you'll see here standard built-in metrics, and there are also HTTP specific metrics, and so on and so forth. So in this case, what we will do is we're going to look for a metric that is of type counter. So you'll see here, this is the metric name, and this is the type of the metric. So if you're looking here at HTTP specific built-in metrics, we're going to see here that the metric HTTP underscore requests is of type counter, and it simply keeps track of how many requests have been sent, right? So this is relatively easy to understand. So I'm going to go ahead and simply copy this. So if you're looking here at how many requests we have sent so far, we can see that in the past we have sent like 50 requests. So how do we say that we expect at least 20 requests or something like that? Well, in that case, we need to use what is called an aggregation method, right? So we need to put here the condition between brackets, and we're going to use here the aggregation method named count. So essentially, on the counter, we're using count, maybe a bit weird, but stick with me for a second. And we're going to say here the count needs to be greater than 20. So what this means is that we expect to send at least 20 requests. Let's go ahead and run this once again. I'm going to simply go ahead and comment this out so that we can have the execution. So no errors at this point. I'm going to fast forward to the end of the report. What you will see here is that this metric is passing. So we are essentially within what we expect. There is also a secondary aggregation method, and this is called rate. Now, essentially, what rate does, it checks how many requests, for example, have been sent per second. So in this case, you see we have 50 requests that we have sent out, but the rate is 4.85 something requests per second. So additionally, what we could do here is say, like, look, we want at least 4 requests per second to be sent out. So we can then use this other aggregation, the rate, and for that, we're going to say we want the rate to be greater than 4. So let's go ahead and run this once again and jump directly to the results. So as you can see here, the rate is above 4, so this threshold is within acceptable limits. Let's imagine that we want to set here a rate of 10, which is something that we currently do not have, just to see that this is working as expected. This time what we're seeing here is that getting this error, threshold on metric HTTP request has been crossed. So, meaning we have not sent 10 requests per second. So this is how this particular type of a metric works. So just to recap, a counter simply keeps track of something, how many requests have been sent, and so on during a period of time. And we have two aggregation methods. We can either use count so that we know, okay, how many requests have been sent. All right, perfect. Let's move on to the next type of metric, and this is a gauge. A gauge metrics in K6 represent like an instant value of something at a particular point in time. You can think of it like the speedometer on a car. Shows you the speed. If you go faster, it goes up. If you go slower, then it slows down, so it shows a different value. So it kind of like changes all the time during the test. Now, for example, there may be situations where you want to make sure that something doesn't go below a specific value or doesn't go higher than a specific value. And this is when these gauges are kind of like interesting. So jumping back here at what we have already from K6, we're going to see here that, for example, virtual users is of type gauge. Now, not saying that this is necessarily a great metric to use in this case, so take it more like an example on how to use it than something that we would actually use in practice. But for example, we can go ahead and write here virtual users. And in this case, for metrics of type gauge, we have only one aggregation method, and this is value. So we can only get like the instant value of this thing. And for this, let's say, for example, we want the number of virtual users to be above 9 all the time. All the time, we want at least 9 virtual users. So we can go ahead and save this and run it once again. So we're going to see here for virtual users, we were never below 10. So we started with 10, we ended with 10. But of course, if we're using stages and we're gradually increasing the number of virtual users, in the beginning, the value in this case will be below 9. So this threshold will fail in that situation. This is why I'm saying it's maybe not the greatest example for a gauge, but it's definitely something that we can take a look at. So just keep in mind, a gauge is like the speedometer on a car. It just shows you some instant value of whatever metric supports this type. And then you can only use the value aggregation method, which is like, it gives you like what is the current value, and this is being checked throughout the execution. Now let's take a look at the rate type. Rate type shows how frequently a non-zero value occurs for something. So let's take a look in the documentation to see what do we have for rate. So if we're looking here at HTTP requests, we're going to see here HTTP request failed is of type rate. So if we're going back here, you're going to see here this error, right? So this is something that we have commented out. So if you run this once again, it's going to tell us that this particular metric has an unsupported aggregation method, and that this metric is of type rate. So this is exactly what we know right now. So we're looking at an example for rate. This is a metric that is of type rate. And it's telling us that for this particular metric of type rate, the only aggregation method that we can use is rate. So there's no count that we can use. So we have to write here rate. Now, what's important about rate is that the rate is the rate of events, and it is calculated by dividing the number of successful events by the total number of events. Now, essentially, the value of rate is something between 0.00 and 1.00. Essentially, this is how we represent percentages. So what do I mean by that? Well, essentially, if I'm saying here the rate should be 0.1, this means that this is less than 10%. Or if I want to say something should be more than equal than 90%, then I will gonna write here rate greater than or equal 0.9. So it's always a value between 0 and 1. So if we go back to this, save it, we're not going to get this error anymore, and the execution will be successful. Another metric type is the trend. And this calculates different statistics and different values. So, for example, it will calculate mean, max, average, but also allows us to have like percentile. So let's take a look if we have anything like trends. If we're taking a look here at the HTTP specific metrics, there are a few that are trends. So for example, we already have in our test here HTTP request duration. So this is a trend. And for that reason, we have used here percentile. But just as well, we can simply use max. So we can use HTTP request duration. And we will say, look, the 95 percentile needs to be below 100 milliseconds, right? But we don't want even the slowest response to be, for example, longer than 2 seconds. So for that, we're going to use the exact same one. So HTTP request duration and between brackets, and we're going to put here max, and we're going to say max needs to be below 2000. So these are 2000 milliseconds, which means 2 seconds. So this we can combine, we can write for the same metric, different conditions. So just to recap, for trends, we have different aggregation methods, average, mean, max, or percentile, as we have an example here with the 95 percentile.